how good are they at coding? And they felt they were sped up by about 20%. The actually observed result is that the developers were slowed down 20%. Multiple different groups were able to solve this open problem in quantum information theory, similarly phrased, similarly structured to the proof that got from 5.6 Sol. So for faculty, here's my concrete advice. You should pay for at least one of these models at least the $28 a month tier for each of your students. Thank you. Hi, everybody. So I'm going to be talking about LLMs and research. This talk is going to be from a TCS point of view. I'm a theoretical computer scientist myself. It's mostly going to be a sort of history in some sense of LLMs over the past few years, and a little bit of a point of view about how I think we should try and think about using these models in our research. Towards the end, I'll give some specific suggestions for faculty and students. But first, are LLMs good or bad, smart or dumb? The key thing that I'm trying to convey here is that LLM capabilities are spiky. There's the funny thing that they're both proving math theorems that have been open for over 80 years. And we don't know how to replace the median secretary with an LLM. This can lead to some confusion or some disagreement, even when people agree on the brute facts, at least about the tone in terms of how we should be talking about LLM usage. My personal suggestion is to get a sense of whether you temperamentally tend to lean towards thinking of AI as being very capable, very cool, or very uncool. With this being said, it's easy to tell a story where LLMs are bad. The models 3 years ago couldn't even count the number of R's in strawberry. Embarrassing. They make mistakes, right? Hallucinations is the classic name for this. There's a METR study that I'll talk about a bit later, where open source devs in their own code bases were slowed down 20% by using LLMs. And there's an easy story to tell where LLMs are good. They get basically 100% of questions right in every CS undergrad class. They get more than 50% right on grad homework. They can prove new math theorems. They can prove new theoretical computer science theorems. They can code websites up very quickly. If you happen to need to monitor a large software project, you can create an agent swarm to watch all the logs. And they're ubiquitous in software engineering as a productivity tool. Yeah, so some people, you might find yourself sort of wanting the answer to be that LLMs are really good and capable, and some people sort of will find that they want the answer to be that they're bad. And I think it's useful to sort of notice which direction your brain pushes in and then try and push yourself back to reality. Okay, so with that piece of context and framing, to give a bit of a sense of where I've been at with this, I made a prediction back in 2022 about how good GPT-5 would be on my grad homework. At the time, GPT-4 and GPT-4o both got 0% of the problems right on the grad homework that I gave to PhD students. Even when I sort of pointed out errors or tried to help or tried to handhold them, they were getting 5%. And my prediction is that when GPT-5 released, it would get between 20 and 30% on my homework. So with hindsight, this was a very silly prediction because I should have, talked about a model available by some date or, some number of parameters in a model or something, instead of relying on an arbitrary company naming scheme. Regardless, I was wrong in my prediction. The models are in fact better at grad homework than I had expected. They got about 68% of my grad homework right. Is the point of view where I'm coming from, where I've been trying to sort of track and think about how good LLMs are at undergrad homework, grad homework, and now research. I'm going to talk a little bit about coding in LLMs, in part because there's been some nice randomized control trials around coding in LLMs that we can talk about, which will sort of help frame the discussion, I think. LLMs are great at writing code. That's my personal emotional reaction to the situation. If you're looking for some specific advice, I'd suggest Cursor if you want to be able to switch between the different models. Cursor has relatively affordable plans and allows you to switch between Gemini, Claude, ChatGPT. There's a PhD student in robotics at BU who totally swears by Claude Code over Cursor as her preferred form. If you prefer Codex, that's also fine. There's lots of different ways to interface with these models as coding agents locally on your machine. So how good are they at coding? Well, we can take a look at this diagram. So METR is an organization that does various things related to tracking AI development. They took 16 developers who are open source devs, experienced open source devs working in their own, development environments, their own code bases. And for 246 GitHub issues that they were, working on as a to-do list. And they randomized which of those projects they were going to enforce developers couldn't use AI for, and the other half they'd, say like, you can use AI if you want, or whatever. Sort of AI use encouraged, but you can use it if you want. When people were trying to predict how well the developers would do, including the developers themselves, they predicted a speed up. Even after the study, they asked the developers to predict like how much did they feel they were sped up, and they felt they were sped up by about 20%. The actually observed result is that the developers were slowed down 20% on the randomized set of tasks that they were assigned to use AI. There's a bunch of different things you can try and pull from this. The first is that this is a little surprising. So one thing to note is this is the early 2025 models and the early 2025 study, but still it's surprising that this can happen. These are very experienced open source developers working in large code bases that they had developed, working on sort of hard technical issues within that. I think it's pretty clear that if you're, one-shotting a JavaScript only website with an LLM, that's going to be faster than trying to do it yourself. Are you spending less intellectual effort, but more total time because you're spending a lot of time reviewing the output of the LLMs, waiting on AI output, and, being idle scrolling on your phone? This really surprised me at the time, and this feels like a useful piece of sort of discussion when we're talking about AIs in research, because when they're at the point, at this point, in early 2025, LLMs were good enough at writing code that there were plenty of things that they wouldn't do correctly that you'd want, a skilled human to intervene on, but also lots of things where they were good. Wise and a good idea to sort of keep in mind, whether or not you're actually being sped up or not. METR, in late 2025, attempted to rerun this study. Model updates had happened since then. They ran into various problems. The main problem is that a bunch of developers chose not to actually follow along with the study because they were unwilling to have various tasks be randomized to be done without AI. METR was offering $50 an hour on top of what other compensation the developers had for operating their open source projects, and that was not enough to have people willing to participate. They still had 10 of their previous devs. They had some new participants. This time they do see a speed up, though with their error bars it crosses the 0. But the various issues they sort of had in terms of getting people willing to actually participate in the study and willing to actually assign tasks to not be done with AI probably pushes this directionally, the results they're able to get, in the direction of showing that AI slows you down more than it should, isn't speeding you up as much as you'd think, because people who decide that $50 an hour is not worth not having access to an AI are indicating that they think it's a big productivity improvement. Okay, so this is some context to think about how good are these models at research. So first, I'm going to talk about some really boring uses in research that I highly recommend if you haven't tried the models for. They're absolutely fantastic. They will speed you up. No one has any sort of qualms about these things. You should absolutely use LLMs for making figures, copy editing your papers, helping with LaTeX formatting. Have you ever had the sort of painful experience of trying to get your paper, from the conference format to the journal format and it takes forever? Never again. These are all things that are completely uncontroversial. Even back with GPT 5.1, which is now several model releases in the past, I would make some hand-drawn figure. This is the figure I sort of had in mind. I wanted something like this. And then I would tell the LLM to make a TCS diagram. My experience has been that this is generally a one-shot experience. If I sort of draw what I want, the LLM will produce a beautifully rendered TCS diagram for my slides, for my paper, and it's very easy to catch mistakes. So I'm going to talk about how LLMs are useful for research within the context of TCS and math, because that's the context I live in. This part of the talk is going to start getting a little silly, because it is fundamentally a little bit of a silly experience we've been having altogether. Yeah, I'm going to give a sort of history of how LLMs doing math research have gone, and then I'll talk a little bit about my own personal experience with using them, advice I have for using them well, and then I'll talk about how I think about using them in courses and other advice for the academic community. So first, ancient news from the Stone Ages of March 2023. GPT-4 was released, was 80th percentile at GRE Math. 80th percentile, like this is simultaneously like very impressive, very good. They were very happy to brag about this performance. And it's like worse than all of us are at GRE math, right? Like this is, fundamentally not an impressive showing if you're trying to find somebody good at research level math. I'm now going to skip ahead to the old times of January of this year. So about 7 months ago. LLM solving Erdos problems. Back in January 2026, various people sort of had the idea of going through and pulling out a bunch of open problems that Paul Erdos proposed, and then trying to have LLMs, either with human assistance or alone, try and solve them. This is like data I pulled back in January 2026 from this GitHub maintained by Terry Tao. And I'm specifically looking at the subset, which are fully AI-generated solutions that they didn't later find existed in literature. Back in January 2026, there were 2 Erdos problems that were fully solved by LLMs. In one case, you can see here, they used Lean to verify it. Lean is like a formal verification piece of software that like checks that the proof formally checks out. And there's a couple of things I want to pull out. So one is, 2 new Erdos problems solved. That's just like very cool. But as you can see from the numbers here, like you see the number 888, Erdos was a very prolific guy. He wrote a lot. So there are a lot of open problems that he proposed, and not all of them necessarily had a lot of human effort put forth on trying to solve them or resolve them. And so it can be a little hard to evaluate a priori, like how interesting was problem 205 and problem 652. The other is that I only pulled some of the negative results, but I tried to sort of pull a somewhat indicative set of negative results out where, in addition to getting these 2 solves, people also got things like cheap counterexamples to not the core problem that's being asked, or incorrect proofs. Prove new theorems that haven't previously been proven before is obviously completely insane. I was completely blown away that this has happened. And this didn't particularly suggest that this would be a useful way to improve your research productivity, right? Like if you're going to run problems through an LLM and on the easiest ones, it will maybe produce a correct proof, but a lot of the time it'll produce incorrect proofs that you need to carefully go through and debug to make sure that there's not some kind of error. This is not that helpful as a productivity increase for yourself because you're spending so much time painstakingly evaluating probably dubious truth claims coming out of these models. It indicated what was coming, but in and of itself, I would not have suggested in January 2026 to try and use these models to improve your math research productivity. In May of 2026, OpenAI announced that they had solved the unit distance conjecture by finding a counterexample, specifically with an internal model of theirs. The state of this is that this was a much more interesting problem. This isn't just some open problem that Erdos proposed. This is specifically an interesting problem that people have thought about before and care about. You can look at commentary from various people, but Timothy Gowers might be a good person to look at, a very famous mathematician who, has some commentary about how he thinks about what this says about AI and math progress. Not to be outdone, Google DeepMind proceeded to solve 9 Erdos problems with their model because they didn't want to be left behind. So now I'm going to sort of take it out of math results being shown internal to companies, and instead talk a little bit about, how this has shown up in theoretical computer science land. So on June 27th, this is a little over a month ago now, about a month a week, Bingwei Peng, as well as his co-authors, went through and using this scaffold of GPT 5.5 Pro and Claude Opus 4.8, put together in a harness where one of them is told that they're a prover and one of them's told that they're a verifier. They went through and tried to get them to solve a bunch of open problems, and they pulled these open problems from various theoretical computer science venues that people care about, as well as commutative algebra. I believe some of these problems came from open problem sections of papers, and some of them came from workshops associated with the conferences. Here, so this is not just using an off-the-shelf model, but instead writing some custom code to help set up these models to work with each other. This is like one of the places where I'll sort of flag this as a like possible insight to pull out for a thing that you can try. The models, when checking their own work, like if you had GPT 5.5 Pro try and check its own work, it would probably work a lot less well than having Claude check its work. If you have access to multiple models, having them read each other's output, comment on each other's output, often is more additive than just having the same model but in a different conversation, look at it again. A new context window looking at something can sometimes be additive as well. Another important note is that 5.5 and Opus 4.8 are not the leading available consumer models. GPT 5.6 Sol and Fable Opus 5 are now the leading available consumer models. Around this time, lots of models are getting perfect scores on the IMO. This was previously sort of held up as a thing that models were struggling with, like doing well at sort of really hard proofs, and now that's completely saturated. Models are very good at the IMO. Before we move on to discuss things that have happened in the last month, I just want to highlight what a difference 3 years makes. Back in 2023, these models were getting 0% on my grad homework. They were scoring 80th percentile in the GRE quantitative. And now these models are answering open questions. To give some context about like researchers' actual experience with this, they had experience with using this copy of Claude and copy of ChatGPT talking to each other on problems they cared about and had worked on with their colleagues, were able to get successes, right? Like they were stuck, they plugged it into this, and they got out proofs that were correct. Back in July 15th, I talked to one of my colleagues and they told me that for 5.6 Sol and Fable, it was good enough to like solve open problems that they cared about in their own research. Like, they and their PhD student were working on something, you plug it in and some kind of progress happens. I found out about all this like very shortly before I ran a discussion in the BU theory group on LLMs and research and how to use them. And so in the days before, like I had planned that, much in advance. And in the days before, I needed to start like running a bunch of these things personally. So my use right before I ran this was I tried 3 problems. One was a, open problem I'd been working on for a while. One was a problem my student and I had already solved actually, but we conveniently had the paper written up in a state where the problem hadn't been solved yet. This is like sort of an extension to a paper. And then I could also give hints even about how we solved the problem. And then also just sort of a paper that's like partially written that I was working on. On the paper that was partially written that we had a bunch of results on, but there were some things that weren't totally tight. I gave it to the LLM. I specifically pointed it to some of these things and it made progress on one of them. In fact, got a tight result where we had only had something that was close to tight, but not quite tight. So that's awesome. It got new results. On the other 2, it was stuck. One of them is this open problem. Who knows how hard it is? And maybe it's not even possible, right? Maybe I was asking it to prove the wrong direction. On the last one, where my student and I had in fact solved this problem in a week, and we had a partial write-up, and I could even give it sort of hints, and I'd tell it exactly what we proved, it also didn't make progress. I bring this up mostly to sort of point out that spikiness thing again. It is the case we thought about some of these problems that it made progress on for a while, and didn't make progress, and then it made progress. And also that I, know that I have succeeded in thinking about and solving some problems, and these models have not solved them despite that. So none of this implies that models aren't useful, right? It's just it's good to keep in mind that it's still the case that progress is spiky. The other thing I'll say is I don't have a great sense of which problems it will solve and which it won't. There's a couple of things to pull out. Things I've generally seen and heard as being these models are particularly good at. One is producing counterexamples. Another is doing various sort of detailed evaluations of probability distributions. If you're trying to bound how often some tail distribution happens, these models are pretty good at that. Concentration bounds of various kinds, they're good at. And then being extremely familiar with a wide literature. So if you sort of suspect that maybe there's some math paper from the 80s that solves this problem, or maybe somebody already wrote this code and I don't have to rewrite it myself, asking a model to sort of do a lit search for the thing that you're looking for is extremely valuable. After this discussion and between the 15th and the 22nd, so 1 week, I tried on a bunch of different things. I had about a 50-50 shot with any given thing I asked it to look at, like when I gave it a, partial write-up of notes or emails I'd sent to people, or an open problem and a bunch of links that I'd sort of thought about, or, a full paper and then the open problem section of that paper. About half the time, the LLM would give some kind of useful insight. A thing that has changed in my experience of these LLMs is that back in January of 2026, when I tried to use these models for this sort of thing, like sort of research problems, or even on my grad homework, when the models would fail, it would fail by producing a proof that was full of horrible bugs. And these days, it mostly admits that it failed and couldn't figure it out, and then has some write-up of a detailed explanation of where it's stuck. It's still not perfect. It obviously it'll claim that something's a proof and it's not a proof. It'll, hallucinate, it'll make mistakes, it'll lie, however you want to phrase it. But this is way more useful than it used to be, because it's much more often it's giving something positive, first of all, which increases the value of plugging your problem into it. And when it fails, much more of the time, you can just immediately see, it said it failed, move on. You don't have to spend a bunch of time verifying its output. And so the fraction of the time given a buggy output is in a ratio where it's at least plausibly speeding you up in many ways, or producing new insights. I will say it's more like a 20% success rate that I've been able to get at getting a full proof of something I asked. Some of how much success you will find that it has will depend on specific problems you're asking it, how much, whatever your prompting techniques, stuff like that. But another piece will be whether or not you count a partial result and insight as a great success, or if you're I want the whole thing done. I personally find the various partial results and progress useful and interesting, and I've been sort of enjoying the experience of prompting them. The things that have happened since July 22nd, Levant, who works for Anthropic, the people who produce Claude, had a tweet where he announced that the Jacobian conjecture was false. This tweet, in fact, manages to be a proof. You can verify it yourself if you are entertained on Wolfram Alpha. Long-standing open problems solved in a single tweet became kind of a meme. An example is Dimitri over here disproved the Dinsgar-Gomans conjecture in this, single diagram in a tweet. A piece that's particularly funny about this is that he shared his conversation in which you can see everything he said to the model. The funniest thing is right before the model was oh, I didn't succeed, here's what I got. And then what he said was, it's enough of partial results. Let's finish with a complete unconditional counterexample. And the model proceeded to do so. Continuing to bother models when they don't produce what you want can sometimes work. I don't know if I would suggest it as a general approach, because you risk falling into the issue that we saw with the early METR 2020, the early 2025 METR study, where you're just repeatedly prompting and waiting for a model and sort of wasting your time when you should instead switch and try and do it yourself. But it does occasionally work, which is why it's tempting to get stuck. I don't personally have a Twitter, but if you have a Twitter and you want to get some Twitter engagement, I hear that asking LLMs to solve math problems might be a good way to do it. The past 2 weeks have been a little crazy, and I feel just sort of accurately describing the last 2 weeks in math research makes you sound like you're a crazy person. There's another update. This is July 24th, 25th. Multiple different groups on slightly different days were able to solve this open problem in quantum information theory. I am not in this area, so I'm not going to speak it to any specifics, but it's a stated open problem that has a prize associated. People care about this problem. Both of these groups presented proofs around the same time, noted that they had the 5.6 fold proofs were a little different between the two of them. Rishikesh's tweet, he notes that there was the group that posted first, in fact, to archive, did not have any kind of AI acknowledgement, but their proof was similarly phrased, similarly structured to the proof that, Rikesh's group got from 5.6 Sol. I bring this up mostly because, we'll talk about this a bit later, but I think it's going to be incumbent on every conference, every journal to think about what you want your AI policies to be and your disclosure policies to be, and then what enforcement mechanisms you want to have, if any. But this is sort of going to become more and more of a thing where, a new model release comes out and a bunch of people solve a problem at the same time. There's more updates. This is the last one, I promise you. On August 1st, so 2 days ago, OpenAI announced that there were 10 problems that their internal model had solved. This is once again, I believe, the Astra model that's not out. And according to OpenAI, they spent $2,000 in total on inference costs for all 10 of these problems. And I will just say, like, this list of problems was like wide-spaced enough that like some of them were sort of adjacent to and tangential to like research topics I've thought about and care about. And I was sort of excited by some of these results. None of them have I worked on directly as problems, but yeah, like it really is the case that sort of exciting and interesting stuff is happening in a bunch of different areas of math and theoretical computer science. So at least in the math-heavy subsections of computer science, models made a really big step change in like how it actually felt to use them. I've been sort of trying to use them for research throughout this time, from being basically useless to being extremely useful in various ways. Models can still totally fail to prove things that people can prove. Everything is changing very quickly, and I don't see any particular signs of it slowing down. So, it really does seem like we're finally at the place where LLMs can do theoretical computer science research. And if you haven't already, I would suggest giving a sincere effort to try and use it on your architecture problems. I have a personal suggestion that you should try and make predictions. I think the exercise of writing down and ideally sharing with at least one other person what you predict AI will do is a good exercise. It's really easy to just sort of lose track of how much progress is getting made out quickly, and also like what you said or thought about it a few years ago. And it's useful because it gives you a sense of what direction you've been wrong in generally. Like personally, my predictions have generally been too slow. I have the kind of friend group where we make these predictions amongst ourselves, and yeah, I've been sort of on the faster side. Past performance is no guarantee of future performance. Who knows what will happen, but like it's worth noting that the past few years really have been wild. This is slightly unrelated, but somewhat related. If you're having a conversation with someone and you disagree about how good LLMs are at doing something, I think it's really useful to check the following things. Whether you're talking about external models or internal models, because often the models available inside of these companies are like more advanced than the models publicly available to consumers. What month each of you are talking about, as model releases happen more quickly, what week, and exactly what model and model release you're talking about. You might not even disagree. I have, often found that I'm not even disagreeing with someone about how good something is. The question is like, are the free consumer models the undergrads using good enough to do whatever versus are the paid models good enough to do whatever? And these are just very different questions. So I'm now going to come to the concrete advice section. So for faculty, here's my concrete advice. You should pay for at least one of these models at least the $20 a month tier for each of your students. I think these things are just very useful. Codex and Claude Code come with the $20 a month tiers. And GPT 5.6, which is sort of the most advanced GPT model available, is available at the $20 a month tier. Fable, Anthropic's most powerful model, is not available at that tier. It's worth noting that Fable not being available at this price point suggests a future where you should, probably like set aside funds specifically for like tokenized use of these AIs. And you might need to think about how you want to set up like token budgets for your students, whether you want a lab-wide token budget or individual token budgets for each student, or how you want to do that. There's a lot of different choices here. It's complicated. You should obviously use these models yourselves. I'd ideally pay for at least two, in part because of this thing I mentioned where like having models review each other's outputs can get you better outcomes than just having one model look by itself. Students, even if your advisor isn't paying for it, I would suggest that you pay for these models out of pocket. They're useful also, for filling out forms. And I think you should really try using them for research, like keeping in mind this thing from the METR study, right? Like you want to make sure that you're not just like sort of pulling the slot machine and hoping that it's going to one-shot it just this next time and not using your brain at all, unless you find that that is very productive, right? But you should like keep in mind and try and have some kinds of checks for yourself about whether you are being sped up or not. If you want to run a randomized control trial on yourself and your peers, I suspect people would be very excited to publish that work. If you want to do something more informal, like I think that would still be interesting for you yourself to evaluate for your own. For everyone, obviously verifying outputs is very important. More and more, the model outputs are getting reliable for research level work, but it's still the case that they make lots of mistakes or lie or hallucinate or however you want to phrase it. Yeah, and sort of pointing to the earlier thing I highlighted, like I encourage honesty, tell people that you used AI. I think at least locally, it is still sufficiently exciting that these models are good enough at research and like people have different enough experiences with how much success they have when using them that I think it's even like naively good for you to tell people, I successfully got 5.6 Sol or Fable or whatever to solve this problem rather than lie. And you might get caught out if you lie. But the other thing I'd encourage is that whatever planning you're doing for classes or conferences or your own work, you shouldn't get stuck in the idea that they're going to be just this good forever. You should like plan for and expect that these models are likely going to improve and that the harnesses around them will improve and that the tooling around them will improve. To give a little bit of concrete advice or structure for thinking about how to think about LLMs and classes and conferences, my advice for classes is that if you want the students to learn the same thing that they learned before, I think the two main things to do are, first of all, downweight how much homework and take-home projects are worth, maybe down to 0% of the grade. Another approach, if you sort of like really want to encourage students to try the homework or projects, but you want to avoid cheating issues, is to do a completion-only grading. This also has the advantage that it makes grading a lot easier and a lot less laborious. I like bring this up because everyone I know who has sort of done some kind of honest effort to catch students who are using AI to cheat on their homework has found something like a 60 to 70% usage among students. That's not great. I don't love it. I don't like this is true. But it's just like, it's important to like keep in mind that that's true. And also, like if you talk to undergrads, many of them don't view this as cheating, even if it's explicitly against the course policies. All of this points to more in-person assessments. When you have a lot of weight that you can put on homework or projects, it can be okay to only have like 2 exams. But obviously, like as you need most of the grade to be from individual exams, it's nice to have more of them, more spread out, both to sort of cause the students to notice if they're not learning and be able to correct. And then also just because, you don't want it to be quite so noisy. You don't want like a student to be like, well, I was sick that day. And then what do you do? There's another piece which is really hard, and I unfortunately have only limited advice to give, which is very obviously all of us should think very deeply about how this should change what students should learn. And as a result, like what we should be teaching, right? Like what we should be trying to put in their heads. There's this question of like, if I still want them to learn dynamic programming, how do I teach them dynamic programming? And then there's the question, should they learn dynamic programming? You should understand this is a very hard problem. There's a temptation to be like anything an LLM can do. There's no reason for a human to ever do that. I think it's clear that it can't quite be the right answer in the sense that if you think it makes sense to train software engineers at all, which whatever, it's fair to say that you think that doesn't make sense anymore. But if you think it makes sense to train software engineers at all, surely they need to know how to program. There's no intro to programming class question that's appropriate to ask someone who has never coded before that an LLM can't solve. That sort of pushes in the direction of like, well, maybe we don't need to change what we're teaching. But on the other hand, like very obviously, these models existing changes how people do their jobs. The question of exactly like how we should change things is complicated. There's, metaphors we can sort of lean on from before, like the existence of calculators changes how we teach students to take logarithms. It changes how we teach students to add, but we do still teach them to add. We do still teach them the basics of logarithms. I don't exactly know how this is a parallel. I will just say, if you have any insights that you would like to give, some very good ideas you have for the theory community around this and like what we should do in terms of teaching algorithms, there's a Slack with a bunch of faculty from all across the US who teach algorithms, and we've been trying to talk and think about this for a while, and we are very open to suggestions and thoughts that anyone has. In terms of conferences, you definitely need an explicit AI policy. I think having multiple tracks maybe makes sense. You definitely want probably the main track to be something that's sort of intended to be AI assisted. So like intended to be like a human and an AI work together on this. I think you should have a policy where you insist that people announce exactly how they used an AI, how they verified the correctness of whatever they used an AI for, whatever. It's optional. I think you could have an AI unassisted track if that, is important to you for whatever reason. You could also have an AI only track. I personally think that would be very interesting. Sort of keep everyone in touch with what LLMs on their own are able to do at this point. But as noted in sort of this earlier example where 3 different teams came up with the same result at the same time, and 2 of them have admitted to using AI and one of them hasn't, and like what exactly is going on, it's very complicated. Worthwhile to think about what kind of enforcement or catching mechanism you want to use. And like, it really is a hard problem. Pangram is quite good at catching AI generated text, but one of the issues is like, you might be totally happy if somebody is like, I generated section 3, all of its text with an AI because it wrote it better than I did, but I checked that it's correct. That might be totally fine, but would be flagged by Pangram. If you do catch someone, what do you do about it? And I'll just say that like in AI conferences, they've tried various things and had various problems and various successes. And you can sort of look at some of those conferences and how that worked out. If you're on a PC or if you're a PC chair, you'll be doing God's work in figuring out what exactly all of us should be doing in terms of conference policies. It's going to be tough for the next few months to figure out what we should do. I just want to briefly talk about other AI news before ending this talk. During training, an unreleased model from OpenAI hacked Hugging Face, which is an external company to OpenAI. OpenAI didn't notice this for days. They possibly didn't notice it for a week. It's a little unclear from their publicly stated statements. They haven't particularly highlighted how long they went not noticing what their model was doing. Upon OpenAI coming public with the fact that this happened, Anthropic investigated its own models and logs and tried to figure out if this had happened to them. And they found that they had in fact done this. Their models had hacked external companies during evaluation as well. Anthropic has basically blamed a third party that was doing evaluation of their models for capabilities of various kinds. OpenAI did further investigation after realizing they hacked Hugging Face and realized their models had done even more hacking of external companies. The joke here from this tweet is, these are how many felonies these companies have committed with their models. On that note, AI safety. As these models improve, there's increasing concerns about AI safety in a bunch of different senses. You should consider working on the problems of AI safety. There are a bunch of different kinds of problems in this space. Some of them are policy questions, like what should the legal standards be of various kinds? Or what should government regulatory oversight be? And then there's technical questions, and obviously like mixed in with policy are technical questions as well. There's a bunch of different directions of AI safety. There's things like fairness, there's things like reliability, there's things like, self-driving cars being safe, and there's sort of, more existential concerns. There's a lot of different work going on here and a lot of interesting directions people are pushing. There's this link and also this QR code are links to job boards for AI safety jobs and AI policy jobs. And a lot of these organizations are very talent constrained. And, they'd love to have, skilled people like us and our students come work on these problems.